Hi, folks. Welcome to another episode of the YugabyteDB Friday Tech Talks. We're going to be talking about Savepoints. I have with me Rob Sami, who is one of the engineers that actually worked on and built this feature. So Rob, why don't you introduce yourself really quickly and we'll get right underway.
Yeah, thanks for joining, folks. I'm Rob. I'm an engineer on the distributed storage and transactions team here at Yugabyte, and I've been here for 2 years and excited to talk to you about Savepoints.
All right, fantastic. So maybe to kick it off, like first off, folks, if you have any questions, as usual, you can ask us here right on the, okay, yeah, that was a good joke by Frank, which is run a Savepoint in case we need to restart. But anyway, so feel free to ask us right here at the LinkedIn chat. You can also join our community Slack, yugabyte.com/Slack to ask us at any time. There's a YFTT channel, or you can just post it in the general channel. Okay, with that, maybe Rob, tell us what is a Savepoint and why it's important, and we can kick it off with how things work and so on and so forth.
Yeah, sure. So a Savepoint is essentially a special mark inside of a transaction. And it sort of saves your progress within a transaction and allows all commands that were executed after it to be rolled back without impacting the transaction.
Fantastic. And yeah, so maybe can we talk about a couple of use cases, or like why you need this, or like a little bit more, or if you have something to present, go for it, present it. We can get started.
No, sorry. So yeah, I'll keep going.
You're not presenting. I don't know if you intended to present.
No.
Okay, if you're not, that's okay. That's fine. No worries.
Yeah. So there are a bunch of reasons you might want to use Savepoints, but the core value add of Savepoints is for allowing you to sort of roll back the progress of your transaction after an operation which has some chance of failure fails without sort of sacrificing all of the work you've done in the transaction. So when you have part of your transaction which is doing some work, like adding a row to a table with a unique index constraint, and you know that 1% of the time that fails and you need to retry some part of the end of that transaction in case you violate that constraint, you can set a save point, try that work, and if it fails, roll right back to before you tried and failed that work, and do it again in a more informed way the second time. So that's sort of the core use case of Savepoints, and Savepoints are used a lot by different tools that are built on top of Postgres, and thereby built on top of Yugabyte implicitly. So JDBC, Driver, SQL, Alchemy, other ORMs use Savepoints. So by building support for Savepoints, we're opening up the surface area of compatibility in YSQL.
Got it. And the feature set as well, right? Like the useful set of features. Okay. So as always, the most interesting part, at least for me, of this this whole series is the hands-on demos, right? So maybe we just jump right in and go from there.
Yeah, sounds good. Let me share. All right. So I am sharing a terminal, which is a shell, a sort of a connection to a Yugabyte cluster. So I'm just going to sort of show off some of these. I'll give you a quick
let's do a basic
features.
Yeah, maybe to start, very basic stuff.
Yeah, so I'm just going to create this table.
Okay.
And let's say we start a transaction and insert into sample 2. So we have one row in there. And let's say we create our save point, and we can insert another row. So this is just a very basic demonstration. Right now we have both of these rows here, and if we roll back to our save point, so these are sort of the two of the core commands you would use to interact with save points. If we roll back to the save point we established before, you'll see that we now only have one of the rows there. We can even commit this and show that only that row was committed.
Got it. So all work done after the save point got taken away, right? Exactly as you said.
Yep.
Okay. So got it. So that's great. So let's talk about a practical scenario where you'd use this, right? Like, is there like an error, or what is a case when you would want to roll back?
Yeah, great. So I did allude to that earlier. So I owe you definitely an example. So let's say we are inserting another row here in this new transaction. And we have a save point. And I'm just going to trigger a unique key constraint violation by inserting this 1, 3. You know, we have 1, 2 here, and 1 is K is the primary key. So this will cause a unique key constraint violation.
Primary key constraint. Got it. Yeah.
Yes,
yeah.
Primary key constraint, exactly. So here, you know, we have an error, and you know, we're not going to be able to do anything here until you know, without save points, we'd have to roll back the whole transaction and start over. But with save points, we can just roll back to the line before the error causing one. And we see we still have 3, 4 inserted. And if we commit, yeah, just works. So we were able to still insert the row that we inserted before the operation which caused the error, and we only had to roll back to right before the error to continue with the transaction.
Great. This is awesome. Okay, so maybe this brings up a question for me. Like, this is useful because the work done up to a certain point is saved, I guess, as the save point actually talks about it. And then the work done after that, you're able to do on top, right? What is the semantics of isolation level when it comes to this? Because like when you roll back to a certain point, what does the transaction see afterwards? Because you know, just like Postgres, YugabyteDB supports multiple isolation levels, and it means something, right? Like what you're able to see inside a transaction. So how does save points interact with isolation levels?
Yeah, it's a great question. So the way I like to think about it is save points are simply checkpoints along the way as you're sending operations to the database, and they should behave exactly as you'd expect in every isolation level, except for the fact that they can save and roll back the operations you made. So, you know, if you roll back to a save point, you are it's as if you're beginning again the transaction from wherever you left off, you know, before you made that save point. So in terms of what values you might read from the database, let's say you're in read committed, you create a save point, you continue, you want to roll back to that save point. It's not as if the reads that you do after that, you know, when you roll back are going to be exactly the same as the reads at the point in time when you created the save point. So there's no sort of connection to real time there. It's just as if the operations that you did after that save point did not happen, and so the reads that you make might include values that have been committed more recently, and you know, way after you created that save point. So I think that's an interesting example that illustrates that save points really are not, you know, orthogonal to isolation levels, and they don't really interact at all with point in time semantics of reads and writes in the database.
Got it. And let's say I know that recently, by the way, like I just have to have an excuse to mention this anyway, that we recently released read committed with pessimistic locking, right? Which is pretty cool in itself. But like inside a save point, like any operation you try would still follow the same like pessimistic or optimistic locking semantics. And if it succeeds, it's going to wait to succeed and succeed if it's pessimistic. If it's optimistic, it's going to go into, the failed state as you showed, and it's going to roll back. And of course, things like primary key constraint violation is something, it doesn't matter optimistic or pessimistic, you're going to fail anyway, right? So is that right? Like it's true even for conflicts?
Yeah. So it is the case that, if you issue any sort of operations in a transaction, they will operate semantically the same in terms of optimistic, pessimistic locking kind of behavior. But one thing that you expect is if you issue a save point and then a bunch of operations after that, rolling back to the previous save point should free those operations from conflicting with other transactions. Let's say, one thing, I'm getting echo actually.
That was me for a second. Sorry. Yeah.
Right. So in the case that you issue a bunch of operations that, in one transaction that could cause conflict in another transaction, and you might expect that if you roll back to a save point, that those operations that you are rolling back no longer will conflict with this operation. And that is mostly true, but because of the distributed nature of our database, you get some sort of eventual semantics in terms of removing those conflicts. But it is exactly the same as we have even without save points. We have similar sort of semantics, and this is something that we can push, is less noticeable when you're using pessimistic locking. So as more of our isolation levels support pessimistic locking, you'll see exactly the semantics that you expect in terms of conflict resolution as well using save points.
Got it. Awesome. All right. Kurt has a question. Hi, Kurt. Welcome. Kurt has a question, and he says these seem like sub-transactions, though he says he realizes they're not. And his question is, I assume that save points cannot span transactions. Is that right?
That's correct. So save points are only relevant within the scope of a transaction. And I think it's actually fair to think of these as sub-transactions. I want to share this one slide I have. So the way we sort of think about save points when we're talking about building out save points is that they are creating divisions in the, let's say you have a sort of a line of all the operations you perform within your transaction. Every save point you create is sort of creating a new boundary in that line, and you can think of every set of operations between these boundaries as sub-transactions. So I think it is actually correct to think about or call these sub-transactions that you're creating on some level. And in fact, the way we persist provisional records, we will persist these records with a sub-transaction ID, and we'll manage the state of what is the live sub-transaction, which sub-transactions are aborted, have been rolled back. We'll manage this at the client, and we'll use the sub-transaction concept to inform the metadata that we use to power all these features.
Yeah, makes sense. The Kurt comes from the MySQL world, so he's probably trying to map the two databases and how these things work. But gotcha. I think now that you have brought this up, Rob, I think maybe you could talk about how save points are built in YugabyteDB. This is already the beginning of that. Like maybe we just talk more about what really happens when you do this.
Yeah, great. So as our viewers may know, Yugabyte is built by reusing most of actual Postgres code base, which gives us just a lot of features for free. And we were able to very easily plug into the client side sort of bookkeeping functionality that Postgres has to keep track of what sub-transactions are live versus rolled back. And all of this sort of just works for us. So what we need to do from there is maintain, send the metadata about what sub-transaction is live, and which of these are rolled back from the client to the T server. So T server is serving reads and writes. And when it receives a read request, let's say, it can know that, you know, subtransaction 1 is no longer live, but 0 and 2 are live. So when it comes to read these provisional records, we see, you know, the transaction ID and the subtransaction ID, and we can effectively mask any provisional records with subtransaction ID equal 1, right?
And in this case, so let's say you've done one subtransaction, and you go ahead and write the provisional records for that with that subtransaction ID. Let's say in this case, you did subtransaction 0, great, and then you're writing a few provisional records for subtransaction 1, right? And then you roll back the save point to, you know, to before 1 started. So you roll back to the beginning of 1. Every time a new like an independent transaction is trying to visit this key, does it go back and resolve the state of this provisional record? How does that piece work? I think that's the piece you said you might be a little lazy about it. Is that right?
Yes, that's exactly right. So when another transaction is performing a read and encounters a provisional record with subtransaction ID equal 1, depending on, you know, there's sort of an asynchronous process whereby the client will heartbeat its metadata about what subtransactions are live to, actually, let me show this. So the client talks to a transaction manager, and asynchronously that will, and this isn't shown here, but I'm just using these as reference points, that will asynchronously send this metadata to each tablet. And so it's just a question of if that read comes in before or after that metadata about which subtransactions are live gets eventually to that tablet. It may or may not see that read, but in terms of in the scope of the transaction, which is writing these provisional records, all semantics are, you know, strongly consistent, and you will always see exactly the records that you expect.
Makes sense. Cool. Okay, so let's maybe go back to the demo, right? I think what would be interesting is to look at, like, I think you talked about, can we have, because it's similar to Postgres and we actually use the Postgres processing engine, I think you mentioned that. How do multiple save points inside a single transaction work, or do they work, or how is that handled?
Yeah, so let me share this again. So let's see. We can start a transaction, and let's say we create one save point and insert. Let's find an insert here. And then we create another save point. So, you know, at this point, we've inserted both these rows, and we can roll back to S2 or S1, whichever one we want. If we roll back to S1, then both of these writes will be wiped out. If we roll back to S2, only this write will be wiped out. You know, it's as if you're coming back to this point in your sort of transactional operation timeline.
Let's say at this point, the transaction decides, look, this is great. I got S1, I got S2. I no longer care about S2. I don't care about that save point. Is it recommended that they just ignore that save point existence and keep moving forward, or can they actually get rid of that save point in the middle of the transaction?
Yeah, so it's a great question that I definitely wanted to touch on. So we can issue, this is basically the, you know, we have save point, we have rollback to save point, and then we have release save point. This is the third and final kind of command in the save points feature umbrella.
But before you do that, can we list save points inside a transaction?
I actually am not sure, to be honest.
Okay, so that just depends on what Postgres does.
Yeah, if Postgres does it, it probably just works.
Okay, awesome. All right, let's keep.
Yeah. So if we release S2 here, then what that is doing is it's sort of leaving Postgres of all the metadata that it needed to track in order to know what S2 is and what it represents. So for example, if we wanted to roll back to S2, it would no longer be a valid operation. But we could still roll back to S1. So yeah, it is recommended to do this. It's a good practice. And another thing to note is that if we create Savepoint S1, we can still create another Savepoint S1 here. And any future references to S1 will refer to the latest created one. So, it's good practice to release these Savepoints, both from a sort of semantic standpoint, so you're not confused about what a Savepoint name is referring to, but also from a sort of overhead perspective. If you're creating a lot of Savepoints, it is definitely recommended to release them so that Postgres can free up the resources it needs to track them.
Got it. Makes sense. Awesome. Fantastic. Okay, so let's go to another a whole interesting area, right? Like YugabyteDB does support stored procedures and the more advanced stuff. Can you talk about how Savepoints will interplay with or do they work or do they interplay with stored procedures? All of that.
Yes. I'm glad you brought this up. I wanted to bring this up next. So Savepoints are Postgres supports stored procedures, so by extension, Yugabyte supports stored procedures. And under the hood, a stored procedure, when running inside of a transaction, will create a Savepoint. So if any error is triggered within that stored procedure, it will be able to roll back to the Savepoint that it implicitly created right before it was run. And so, by supporting Savepoints in Yugabyte, we get this functionality for free as well. So let me just demonstrate that. So let's say we create a Savepoint S1 and we insert into, I just want to insert a row so we can kind of show what state we're at here. 101, 102. And then I actually have a stored procedure kind of written out here. It's just to save time,
right?
For a little bit longer, but we'll talk about what it's doing. So this insert stored procedure, it is very simply inserting this row, 9, 10, 11, 12, and then it prints, hey, I'm here, just so we can see it, and then inserts this row 1, 7, which will conflict, if you see up here, with 1, 2. And then on exception, we print this just to say, hey, we're here, and we update instead of insert, which should just work. And so what we expect to happen here is when this insert fails, Postgres Yugabyte will roll back to the point before any of these operations were created inside of this block statement, and then execute these operations. So we can see that here. So yeah, we see got here, and then it got here. So now if we look at the rows in our sample table, we see the original row is inserted. This row is updated, and neither of these rows is able to be salvaged because they weren't explicitly handled or retried in this exception handling block. But you can see that we rolled back to before any of these operations were created, and then we resumed here.
Got it. And here you don't need to explicitly define the save point?
Correct. So it's just implicitly defined. We can, for example, so we're still inside of a transaction.
We still create this. Oh, okay, we still are. Yeah. Oh, okay, got it. Yeah, got it. Yeah. Okay.
So just to illustrate, so we did create this save point up here. That has actually nothing to do with the save point that is implicitly created when you call insert. For example, if we roll back to S1, we can see all of the changes are gone. So yeah, nothing explicit needed to be done here. It's just implicitly created right before you call insert, and on exception, it rolls back to that save point and calls the exception handling block.
Fantastic. I think this is quite interesting. I think as a side note, I think it's quite interesting that you can create a stored procedure inside a transaction. Anyway, so that's just a cool feature. I think you don't have to come out of it. I think moving forward, right? Like, is there a use for save points inside the stored procedure block itself? Would that work?
That's a good question, and I believe the answer is yes. And I'm not actually too sure about the use cases there, but
yeah, I'm not sure. Also, I was just curious for sake. So
yeah, I think it should work. If you were to, create a save point inside of here and then roll back to it within the context of the stored procedure, yeah, it should just work.
Great. Okay, so last couple of things, right? So what is the performance impact of a save point in YugabyteDB? I know that the way it's handled is different, right, between Postgres and YugabyteDB. So what does YugabyteDB do? What is the performance implication?
Yeah, so let me see. Do I have anything to sort of share here? The short answer is there is not a big performance implication at all. Let me actually just share this. Going back to this picture, we're maintaining metadata about what subtransaction is currently live and which ones have been created or rolled back, all at the client. We're sending this in the read and write requests that we send to tablet servers. And
so this is so just to get this right, this is actually metadata maintained in the memory of the transaction processor, the query coordinator, right? So the query hits a node. That node's Postgres upper half actually is the one that maintains the save point in memory. There's really no write to disk. And so the implications in terms of what it takes with respect to round trips or what you can do, they're not like anything significant. And the implication in terms of the memory taken, would you say that's comparable to what Postgres does?
Yeah, no, it's exactly what Postgres does. We're reusing exactly the same code. So it is exactly as Postgres behaves there. And,
got it. And we would have written these provisional records anyway, and now we write these provisional records. The only extra thing is that subtransaction ID, correct?
Yep, right here. And, we include this in the read and write request, which is, a very small addition. So
got
just
it.
a int32. So.
Got it. Great. And what is the impact on availability? Like, let's say you're running this and you're running this on you have a 10 node cluster, and it's like you have a transaction that's hitting all of the 10 nodes to do various inserts, right? And let's say node 1 is processing the transaction that's hitting all of this stuff, and you have a save point created, and one of the other nodes die. Does that impact the save point feature in any way? I don't think it should, but I just wanted to confirm. It should be the same as without a save point. There's really no impact on resilience, right?
That's right. As long as the Postgres process that you're talking to remains alive, all of this works as resilient as any other feature that you've grown accustomed to in YSQL.
Got it. Yeah, if the process actually coordinating the transaction dies, then well, your client connection is terminated, and you have to. There's a different problem, right? So,
yep.
Okay,
yep.
Got it. Fantastic. Thank you. This was awesome. Anything else you want to tell us, Rob?
No, I mean, I think that we've covered all the bases. So.
Yeah. Fantastic. All right. Any other questions, folks? I think we have a minute left, but I think there were some good questions. I think there's some interesting things out of Postgres that would be good to have, like listing save points. And I think the other one is probably going back to the last known save point without knowing its name would be another interesting addition. But yeah, it's fine. I think it's these are, I guess it's never done. So awesome. Yeah, Kurt says thanks. Another great YFTT. Thank you, Kurt. Really appreciate it. Thank you, folks. I think if you have other questions, feel free to join us on our community Slack, yugabyte.com/Slack. Just pop into the YFTT channel. We're happy to connect with you. Rob is going to hang out there and answer questions. I mean, now, and if not, he'll get back to you at some point also. And once again, join us next week, same place, same time, for another YFTT session. And Thanks.
Thanks, folks.